respectively. Find the sum of the forces moment about the midpoint of BC. So, from the figure we get that ABC is a triangle, B equal 120 degree, and AC equal 12 root 3. So, OA equal 6 root 3 centimeter. And now we say in triangle BOC, BC equal 12. Also, BO equal 6 centimeter. Tends to DK equal 3 centimeter. And in triangle BDE, since DB equal 6 centimeter, therefore DE equal 3 root 3 centimeter. Now, to taking the moment about the point D, we say MD equal 6 multiply DK minus 8 root 3 times DE, or 6 times 3, 8 root 3 times 3 root 3 equal 18 minus 72 equal minus 54 Newton centimeter. Example 2. ABC is an equilateral triangle whose side length is 20 centimeter. Forces of magnitude 100, 200, and 300 Newton act along AB, BC, and AC respectively. Find the algebraic sum of the moments of the forces about the point of intersection of the normals to the triangle and about the midpoint of BC. Now we say in triangle ABD, since AD equal AB sine 60 or 20 sine 60, which is equal to 10 root 3 centimeter. So, OD equal 10 root 3 divided 3 centimeter. Therefore, we say OD equal 10 root 3 divided 3 centimeter. Now, to taking moment about the point O, we say 100 times OE plus 200 times OD minus 300 times OK. So it's equal 100 plus 200 minus 300, all of them times 10 root 3 over 3, which equal to 0. And in triangle BDH, we say since DH equal BD sine 60 or 10 sine 60, which equals to 5 root 3 centimeter. So, to take the moment about point D equal 100 times 5 root 3 minus 300 times 5 root 3, which is equal 1000 root 3 Newton centimeter. Another one. ABCD is a rhombus whose side is 12 centimeter. Measure of A equals 60. Forces of magnitude 11, 6, 5, and 7 Newton act along BA, BC, DC, and DB respectively. Now, find the algebraic sum of the moments of the forces about A and about the point of intersection of its diagonals. From the figure, we notice that triangle ADE, where AE equal AD sine 60 or sine 60 root 3 centimeter. Also, we say AO equal 6 root 3 centimeter. Now, To take the moment about the point A, we say 7 times AO plus 5 times A minus 6 times AE, which is equal to 7 plus 5 minus 6 times 6 root 3, which is equal to 36 root 3 Newton centimeter. Now, in triangle BOA, BO equal AB sine 30, which is equal to 12 sine 30 or equal 6 centimeter. And we say in triangle BOK, OK equal BO sine 60, which is equal to 3 root 3 centimeter. Now, to take the moment about the point O, or the center, we say 6 minus 5 minus 11 times length of OK, which is equal to minus 10 multiply 3 root 3 or equal minus 30 root 3 Newton centimeter. And we say the norm equal positive 30 root 3 Newton centimeter. Let us taking another one. ABC is an isosceles triangle in which measure of A equal 120 degree. Forces of magnitude 4 and 4 root 3 kilogram weight are acting along the sides of AB, AC, and BC, respectively. Prove that the line of action of the resultant of these forces passing through the midpoint of BC and parallel to AC. As solution, we say, let AD equal L and AC equal AB equal to L. So, the moment about the point A equal 4 root 3 times L, kilogram weight. Also, in triangle BAK, where BK equal BA sine 60 or equal 2L sine 60, which is equal to L root 3 centimeter. Now, the moment about the point M, we say that about B, we say that minus 4 times BK, which is equal minus 4L root 3 kilogram weight as number 2. Now, MC equal the moment about point C equal 4 times CE equal 4 times L root 3 equal 4 root 3 L kilogram weight. Number 3. Now we notice that from equation 2 and 3, MB equal minus MC. So we can say the line of action of the resultant bisects BC. Also from 1 and 3, we get that MA, moment about A, equals the moment about C. So we say the line of action of the resultant parallel to AC. ABCD is a rectangle in which AB equals 6 centimeter, BC equal 8 centimeter. Forces of magnitudes 5, 8, 6, and 10 gram weight act along BA, BC, CD, CA respectively. Find the point E, which belong to straight line BC, so that the sum of the forces moment about E equal 45 gram weight centimeter in direction of A, B, C, D. As solution we say let measure of ACB equal alpha. So sine alpha equal AB over AC, which is equal to another triangle EK over EC. Notice we find sine alpha in two triangles and it is the same. So 6 over 10 equal EK over X, or EK equal 3 over 5 X. And we say, since the moment about point E equal 6 times X plus 10 times EK minus 5 times 8 minus X, so we say 45 equal 6x plus 10 times 3 over 5x minus 40 plus 5x, or we say 45 plus 40 equal 6x plus 6x plus 5x, or we say 85 equal 17x. So x equal 5 centimeter, or we say at 5 centimeter from the point C. Another one. ABCD is a square of side lengths 6 centimeter. Forces of magnitude 1, 2, 3, 4, and F Newton act in direction of AB, BC, CD, DA, and AC respectively. Now, if the line of action of the resultant passes through the point E, which belongs to BC, where BE equal 1 centimeter, find the value of F. As solution we say, in triangle ECK, we notice that EK equal EC sine 45, or we say 5 root 2 over 2 centimeter. Now, to find the line of action of the resultant passing through the point E, we say that ME equals 0. Now, we say since the line of action of the resultant passing through the point E, so ME equals 0, or the moment about the point E equals 0. And we can substitute in it. We take that 1 times 1 plus 3 times 5 plus 4 times 6 minus F times 5 root 2 divided 2, which is equal to 0. And we get that 40 equal 5 root 2 over 2F, which tends to F equal 8 root 2 Newton. Another one. ABCD is a rectangle in which AB equal 6 centimeter, BC equal 10 centimeter. The forces of magnitude 4, 5, F, and 2 gram weight act along AB, BC, DC, and AD respectively. Now, find the value of F, given that the sum of the forces moment about the point A equals 0. Then find the point E such that the sum of the forces moment at E equals 0 in direction of A, B, C, D, where E belongs to B, C. Now, from the figure we say that since MA equals 0, so 5 times 6 minus F times 10 equals 0. And we get that 30 equal 10F, or F equal 3 kilogram weight. And now, let BE equal X, which EC equal 10 minus X. So we say, since the line of action passes through by E, we say that moment about E equals 0. And we get 4 times X minus F times 10 minus X minus 2 times 6 equals 0. Now solve this equation, get 4X minus 3 times 10 minus X equal 12. And 4X minus 30 plus 3X equal 12. Or we say 7X equal 42. And the value of X equal 6 centimeter from the point B. ABCD is a square of side length 8 centimeter. Forces of magnitude 2, 5, K, 7, 6 root 2, and 8 root 2 Newton act along AB, CB, CD, AD, AC, and DB, respectively. Now, find the value of K, given that the moment about B equals the moment about C. As solution, we say that in the square ABC, since AB equal 8 centimeter, therefore AC equal BD equal 8 root 2 centimeter, and BO equal CO equal 4 root 2 centimeter. Now, the moment about the point B equal K multiply 8 minus 7 multiply 8 minus 6 root 2 times 4 root 2. Or we say 8K minus 56 minus 48, or 8K minus 104 as equation 1. Also we say the moment about C equal 2 times 8 plus 8 root 2 times 4 root 2 minus 7 times 8, which is equal to 16 plus 64 minus 56, or equal 24 as second equation. Now, as the given, we get that since MB equal MC, so you say 8K minus 104 equal 24, or 8K equal 24 plus 104, which is equal to 128. So the value of K equal 16 Newton. A, B, C, D, E, F is a regular hexagon. Forces of magnitude 80, 60, F, and 40 gram. Weight act along AB, BC, CD, and ED respectively. Now, if the sum of moment of these forces vanish about the point or vertex A, find the value of F. Then find the moment about its center O. From the given we say, therefore MA equals 0. So 60 times AK plus F times AC minus 40 times AE equals 0. So 60 times L root 3 over 2 plus F times L root 3 minus 40 times L root 3 equals 0. All of them divided L root 3, we say that 30 minus F minus 40 equals 0. So F equal 10 gram weight. Now, the moment about the center O, it's equal to 80 plus 60 plus 10 minus 40. All of them times the same length, L root 3 over 2, which gives 55 root 3 gram weight. Another one. ABCD is a rectangle in which AB equal 8 centimeter, BC equal 12 centimeter. Forces of magnitude 16, 14, L and N. Gram weight act along the direction of AB, CB, CD and AD respectively. Now, if the algebraic sum of the moment of these forces about C and about the center of rectangle equal to 0, find the value of L and N. From the figure we say OE equal half of AB, which is equal to 4 centimeter, and OK equal half of BC equal 6 centimeter, and since the moment about C equals 0, therefore 16 times 12 minus N times 8 equals 0, or 16 times 12 equal 8, or 8 times N, or N equal 24 gram weight. Also, since the moment about the center equals 0, we say 16 times 6 minus 14 times 4 plus L times 6 minus 24 times 4 equal to 0. So 6L equal 56, or L equal 28 over 3, which is equal to 9 1/3 gram weight. Another one. ABCD is trapezium in which AD parallel to BC. Measure of angle A equal 90. AB equal AD equal 10 centimeter. And BC equal 20 centimeter. Now, forces of magnitude K 5, F 5, 10 root 2 Newton act along BA, CB, DC, DA, DB respectively. If the sum of the forces moment about the point A vanished and the sum of the forces moment about B equal that at D. Now, find the value of F and K. From the given, we say, since ABCD is a square, we say that BD equal 10 root 2 and BO equal 5 root 2. Also, AE equal 5 root 2 centimeter. And now, since the moment about the point A is vanished, so we say MA equal 0 and 10 root 2 times AO minus 5 times AB minus F times AE equals 0. So 10 root 2 times 5 root 2 minus 5 times 10 minus F times 5 root 2 equals 0. And 100 minus 50 equal 5 root 2 F. Or F equal 50 divided 5 root 2, which is equal 5 root 2 Newton. Now, as the second required, we say, since MB equal MD, therefore we say 5 times AB minus F times BD equal minus K times AD minus 5 times DH. So 5 times 10 minus 5 root 2 times 10 root 2 equal minus K times 10 minus 5 times 10, or 50 minus 100 equal minus 10K minus 50. 10K equal minus 50 plus 100, which is equal to 0. So we say K equals 0. Thank you and goodbye.